Hi, I'm George Crump with VergeIO. Thanks for joining us today. Joining me today is Bob Montanog. He is a senior principal solutions architect with VergeIO. Bob, thanks for joining us.
Yep. Thanks for having me, George.
So, Bob is our worldwide expert on networking. And so there's no better person I thought to help us out with this conversation. Bob, I think one of the unique things that frankly maybe we're a little guilty of not talking about enough is the integrated software defined networking capabilities that we have built into VergeOS. What do you think?
Yeah, it's actually one of my favorite things to talk about when I'm doing demos because we are, one of the strongest aspects we have within VergeOS is our very robust storage options, but not talked about as much is the fact that we have a full-blown SDN stack built in to the OS and made very easily available to users, not only just through a web UI, but also through a REST API.
And does that the fact that it's built in, what are some advantages? I would assume, I'm hoping that that makes it so mere mortals that aren't network gurus like you are able to pick this up and do, kind of cool networking stuff, even though they might not have all the abbreviations that networking guys like so much memorized.
Yeah, we do love our abbreviations. Yeah, yeah. It makes things really, really easy for folks, even if you don't necessarily have a background in networking. Heck, I actually didn't myself either. My whole intro to networking has been done entirely through the virtual realm. Now, that said, it's also going out now to the physical side as well too. But originally, yeah, I started off with having virtual networks available to me, which, even again, if you aren't in a background of networking makes things very easy to pick up because you can easily create and destroy networks and change them up as need be without having to physically walk back and forth with like a serial cable or having to, SSH into some sort of out of band management interface to change up configs or roll back configs.
Makes sense. And then one of the other things that I think is interesting about networking or software-defined networking is that it sort of frees you a little bit from a hardware perspective. You can use a lot of different switches and things like that, right?
Hmm. Correct. Yeah, for us, I mean, our only real requirement for any kind of physical networking is going to be the ability to turn on jumbo frames. So that's going to be probably in just about any switch created in the last at least 15 years, if not more at this point. So yeah, as far as hardware goes, we work just fine with existing hardware, and we can even integrate in some pieces such as, dynamic routing over BGP.
Yeah. And I think that so this the reason I bring that up is and it's not just, I mean, obviously there's a cost savings there, but I was speaking to a customer last week who they had acquired a few companies, and of course each company had different networking, right? Well, with our software defined networking capability, you could put a, if you will, a universal interface on top of all that, right?
Yeah, we make things really, really easy and flexible when it comes to either creating or recreating or, just having any type of network topology, in terms of both layer three and layer two within a Verge system. So if you need to recreate subnets in the terms of maybe migrations or sandboxing, we can spin up multiple networks of the same subnet, you know, even having VMs with the same MAC addresses, but they're all kept on different layer two networks so that they never really interfere with one another.
That's really cool. Well, one of the things I like to do is not show PowerPoint slides and just jump right into demos. So, and what I want to do is sort of just take our, feature checklist that we do and just have you kind of where it makes sense to just sort of demonstrate some capabilities. And just so the audience knows, I'm going to slow Bob down a little bit every so often because I'm a storage guy and the network guys have an unprecedented skill of being able to whip out 3 and 4 letter acronyms. I think even there's some 5 letter acronyms just for good measure. So yeah, there is. I just see one right there. So don't worry. And I think one of the things we really want to get across here is you don't have to start today with being a networking stud to take advantage of some of this. But if you're a networking stud, you're going to really enjoy it as well. Is that fair?
That is very fair. Yep.
Okay. Well, let's just jump into, and I made you do this one first because it's the one I get the most because of my disaster recovery background. But let's talk about BGP, and I challenge you to set up a really cool demo for that. So why don't we start there and go from there?
Before I even talk about this, though, just a quick primer on what BGP is to the folks who maybe aren't familiar with it. So, BGP stands for Gateway Protocol. It is a form of dynamic routing that is, there are other ones such as OSPF and EIGRP. This one in particular is good for situations where maybe you have disparate sites and perhaps they want to have the same subnet available on both sites, but you want to ensure there's an automated failing over of some sort of router that says, hey, okay, this site one is down. I'm going to site two now because I want this site to be serving out this given subnet. It's also very good at kind of figuring out what is the best path to get to, one site or another, based on, both user set configuration options and also things that it learns itself. It's very, very robust. There are a lot of configurable options with regards to BGP, and it's great in disaster recovery failovers because it allows for what we call fast route convergence. And route convergence is really the act of, kind of determining what is the best place for a route to go and who owns what routes. And a route is really just a matter of saying, I need to go to this network, and to get to this network, I need to go to X location. And BGP is great at taking in, all these various routers that might be advertising different subnets and kind of getting a sane list of, okay, to get to X, you need to go to Y. To get to Z, you need to go to X. It can do all that for you. And it can reconfigure it on the fly by itself without any user intervention. So today, what I'm going to be showing you folks is something that I have in my own home lab here. And just as a very, high level network topology, I have my own ISP router. Pretty much it's just a modem in this case here that is connected to some networking gear I have, and that serves out to the internet. But below that, I have a pfSense appliance I stood up, and that pfSense appliance is going to be my north router, essentially the router that all of my other Verge routers are going to be peering to. Now, that said, when you're running Verge, you don't have to have some external entity acting as your primary peer for various routers. You could have Verge running this. I just want to show that, we do integrate with other existing solutions, whether it's going to be, Cisco gear, Arista gear, other virtual networking options like pfSense, even if it's a physical pfSense appliance. Doesn't matter. We're all using the same protocol here. And below this pfSense, which there I have a transit network of 192.168.110.0. This is a network that all my routers are part of with at least one interface in it. My first site has a router where it also has an IP address on that 192.168.110.0 network where it's a .20. My other site also has one with a .30. This allows, my primary router that gets out to the internet to talk to my other routers at these two sites on the same subnet. All right. Now, below each of these routers, I am serving essentially the same subnet, which is 192.168.125.0/24. And on that network is a VM I've created with the .2 IP address, so 192.168.125.2, that is running a website. And this website, I'm trying to essentially access, I'm coming in through, because it's on my own home network, this 172.16.1.58 address. So when I hit this router is essentially going to tell me which site to go to based on which path is up. Now you'll notice I have implemented some BGP wait options on my neighbors for these specific routes. So in my case here, because it has a higher weight, my site 1 router is going to have the preferential path to get to this VM. But with how awesome BGP is, I could just completely just shut down this network, and immediately traffic will start going over to this other site, and will go down to my other instance of this VM running the exact same website with the exact same IP address. And there won't be any noticeable change by anybody coming in to try to hit that website. In addition to that, just some quick asides about BGP config options. I'm trying to keep it as simple as possible here. So all I'm really doing is from this northbound router, I'm doing a default originate to both of my two downstream routers. And then really from each of these two routers, I'm advertising the 192.168.125.0/24 network up into this northbound router. They are all part of the same interior AS, which is 65100. And technically, this would be kind of classified more as an IBGP setup. I am not meshing fully. The main reason for that is I am distributing non-unique routes. Again, I have that same subnet being advertised by both sides. So that's why I don't have a link up between my two south routers here. All right. So what does this actually look like in practice? All right. Here is my Verge Site 1 site. Here is my Verge Site 2 site. On Site 1, I have the VM that's actually running the website. That's this guy right here. And if I just go into the console and I do a IPA, you'll see that it's running 192.168.125.2. If I come over here to my other site and I also go to my website VM, you will see that it is also running 192.168.125.2. Now, the big difference here is on my second site, it's going up to, a .1, and that .1 is going to that .30 address we saw. Same thing over here. This is also going to its own .1, but that .1 is going to the .20 address. Now, I actually have the website in question open over here. It is I'm running Nginx, and I'm just running a very simple site that really just says the IP address of the site and which site it's currently on. And I could refresh this as much as I want, and it's currently going to site 1. And the reason for that is if I go to my pfSense appliance that's acting as the north appliance in all of this, if you take a look at the routes I currently have, you'll notice that for the subnet this website's running on, it's currently being served out through the .20 address. If we go down here to the list of BGP routes, you'll notice that both .20 and .30 are serving out that subnet, but I'm actually pointing to the one that's getting served out of .20, and it's listed as the best one. And the reason for that is, you'll notice I have a higher weight value on this. So what this can do is, let's say I have someone hitting this website over and over and over again, but maybe for some reason, someone unplugs something, host goes down, there's a power outage, who knows? I'm going to turn this network off. And by the way, this is the network that's serving that out. You'll notice that it has the IP address of 110.20. Just to also show you here how we actually configure those BGP options. If you go into routers, you can essentially, pick your route options by AS. And you'll see here again, fairly simple. I'm not really doing anything crazy here, but you can get a lot more options in here if you want. Pretty much if it's compatible with FR routing, we can do it in here. All right. So if I go back in here and let's say I just power off this network, we come back over to site 1. I hit refresh. We're already going to 2. And apparently site 2 really has a strong opinion of site 1. I didn't know that, but I'll have to talk to the folks who run that site because my goodness.
Yeah. Well, at least they kept it kind of clean, though.
Yeah, true. They kept it very PG, if nothing else.
Yes, yes.
And then if we look at our routes now from the northbound router, you will now notice that subnet is now being served out of .30. And if we go down to our BGP routes, you'll notice .20 is not available anymore because it is no longer a neighbor and it's not currently talking to my northbound router. But I mean, you saw how quickly I shut it down. I came over here and, we're already on site 2. So let's say, site 1 comes back up. How quickly will it go back over? Powering it back on, refresh, and we're back. That took 2 hits of the refresh button within, 3 seconds? So I also have some fairly aggressive hold down and failover timers set up for both of my sites. For anyone that's not familiar with BGP, pretty much it's a way to kind of configure how quickly, routers will change to the other, possible route for a given subnet. You can have those timers be fairly long, fairly short. Typically, I like to keep them short just so that, if you actually have an outage, things really don't go down. But yeah, that's
So
the power of BGP here.
Yeah. So, Bob, a couple of questions have come in. Let's take those in line. And by the way, feel free to ask questions. We'll address them as we go. If you're listening on demand, feel free to just email us questions at uh, let's see. Let's do info@verge.io. We can pick them up that way. Anyways, so the first question is, so this is impressive in a home lab. What would be some of the considerations when you put it into a data center with multiple servers and things like that?
So, I mean, again, depending on which dynamic routing you want to go with, um, and again, you might even combine something like OSPF with BGP. One of the more popular type of topologies I would see in a production environment is for their virtual networks to advertise them up into perhaps the existing corporate BGP infrastructure. Perhaps do OSPF within a given Verge environment, and then have a singular router or routers in Verge, virtual ones, advertise and participate in some kind of either probably interior or internal BGP setup with some existing router or switch that's in hardware. And then what you'd want to do then is you can have these routes, much like how I'm weighing them on one side versus the other, advertise those routes, or perhaps it's what we call a summarized route, where it's just a one line route that contains all the subnets for a given network, combining a bunch of /24s into, I don't know, a /16 or something. um and have that weight on one side but not the other. And then you can essentially duplicate what I'm doing here, where if a site goes down and you either have VMs up and running or you need to fail over those VMs, you would just honestly, you wouldn't have to do anything if the site's actually down and you have both sites joined via BGP. And these sites could be completely separate geographical sites too. You can have the routing automatically flow over to that other site and hit those same VMs that have now been restored through Verge snapshots without really any kind of a blip of an outage. Um, Again, for anything coming in from the internet, typically that networking can be done either in physical land or in virtual, again with Verge. Um, but in that case too, if a whole Verge site goes down and it's serving out the public IP, you're going to have to essentially have it reroute to another Verge site anyways. That could also possibly be done with BGP as well, if you have both Verge sites, joined to some kind of a public AS or autonomous network or autonomous system really for BGP here.
So another question came in, Bob, and I think it's actually a good one. What we wanted to do is jump right in here and kind of show you something cool, if you will, so you can see just how easy disaster recovery would work. But let's give the folks an overview. We don't want to go through the whole interface, obviously, because that would take a webinar by itself. But show how easy it is to, because I want to make sure everybody understands this is part of VergeOS. This is not an add-on software or anything like that. Unless I'm mistaken, Bob, you didn't install a bunch of VMs to make all this work other than the site VMs, right?
Nope. So I have a background with NSX, and with NSX, and you may notice there's a lot of similarities here in terms of feature sets. I don't have something like an NSX manager or managers. I do not have any NSX controllers. I do not have anything that's designated as an edge node. I don't have specific, physical hypervisors dedicated to running those edge nodes. This is all on the same hardware I'm running all of my VMs on, without the overhead of all of these additional management VMs. So, for folks that aren't familiar with it, NSX has a fairly large footprint when it comes to its installation. The manager nodes themselves, what serves out, the web UI and the management plane for NSX, can be as much as 32 gigabytes of RAM just for one management VM. And typically, you want something running redundant where you have multiple NSX managers. So if you're running two, that's already 64 gigs of RAM just being used by your network management plane. Add in controller VMs where they can be as much as 8 to 16 gigs of RAM each. Edge nodes, which, those can be quite big. You can go as high as 32, 64 gigs of RAM for an edge node. You're looking at hundreds of gigabytes of RAM being used by honestly just the supporting infrastructure to do virtual networking. In Verge, our footprint is for any of these networks. If it's a network that has an IP address on it, it gets turned into a container. So in the background, these networks are actually containers and they run a number of services. And those containers have a footprint of, anywhere honestly between 50 to 250 megabytes of memory each. Now, obviously, that number can go up if you're running a whole bunch of services at once. Like if I'm doing multiple VPNs and I'm doing things like dynamic routing and I have a bunch of firewall rules and, I'm also running DNS or DHCP, yeah, you could probably get that up to, closer to 500, 600, 700 megabytes for a network, but that's really the extreme case here. And again, that's without all that additional overhead, hundreds of gigabytes of memory just for being able to stand those things up. So, yeah, pretty large benefit there.
So since it's on the screen right now, can you explain for the folks what the difference in our lingo, what the difference between an internal and an external network is?
Totally. So, an external network is going to be a representation of some form of external to the virtual environment layer 2 network. If you're familiar with the VMware terminology, I would say the closest equivalent here is a port group. If I were to go in and create a new external network, if I were to set this IP address type to none, and I have my layer 2 type set to VLAN, you'll notice we have some other options here too. I could say something like 500. I could call this VLAN 500, and I will set it to be using a physical Verge network, which is kind of like our equivalent of a distributed virtual switch that really abstracts the physical uplinks. And I can go to submit, and this is already made. It just doesn't refresh yet. There we go. Any VMs, and if I assign a VM's NIC to this network, it's going to get tagged with VLAN 500 going out and untagged for that VLAN coming back in. Much like a port group would in vSphere, that's just tagged for a given VLAN. That is the simplest way we do networks here. Again, if that's all you ever want to do with your networks, that's totally fine. But where the fun comes into play here is if I took one of those other networks and let's say, for instance, I wanted to give it an IP address. So same thing here. This is on VLAN 37. But I've given this an IP address of 192.168.37.10. And I'm also doing a whole lot more here. This network now acts as a primary gateway for any VMs that may be running on this. So now I've lowered the possible hop counts down because this could be, VMs just really going over the same switch. It could be VMs in the same host as this network. And you're hitting the amount of traffic that's actually hitting external entities here. But to that end, there's other things we can do with it. And George, if you're okay, I'd like to kind of just show off some of the other features here of a network, at
Sure.
least an
Go ahead.
external network. Yeah, once it's given an IP address, we can do full-blown layer 3, layer 4 firewall rules, full 5-tuple firewall rules, where, if I go in here, I go to new, pretty much I can have anything be an accept, drop, to reject. I can have those rules based on any given protocol. We do allow for targeting the initial connection as far as both incoming and outgoing. We are a stateful firewall, so you don't need to make rules for both directions for everything. We do allow you to pin rules to the top or bottom. Because we are more of a typical firewall here, we do process rules from the top down. So when traffic hits a given rule, it's going to be evaluated by that rule and then move on to the next one. But you'll notice also in here, besides firewall rules, I have my NAT rules, and I also have some static routes. So our rules section of a external network, or even an internal network, is really just a place to configure your firewall rules, your routes, and also your NAT rules. Now, the difference between an external network and an internal network, before I go any further here, is really just a matter of layer 2. So an external network is going to have its layer 2 be some kind of a VLAN, like a real physical VLAN. An internal network, if I go here, you'll notice some of the things have changed up a little bit. I can still have none if I want to, but really you'll notice there's no layer 2 option specified here. And there's a reason for that. The reason is everything for an internal network runs its layer 2 over a dynamically created VXLAN overlay. So that's one of the really cool things about us in Verge. We're able to do things like overlays without all the complicated setup steps that you would have in something like NSX, when trying to set up either VXLAN or Geneve. So in here, I could call this just, internal network. I could, give this, I don't know, 10.0.0. Call this 100. And then we're going to say it's part of the 10.0.0.0/24 network. And, I can either have it serve out a full-blown instance of bind. I can have it just act as a simple resolver where maybe I'm having all DNS queries pointed to this .100 go out to 1.1.1.1. And then I can also choose to have this network actually route out of an existing one if I want, or not at all. If you want to have a completely isolated network, or perhaps have another VM on this network act as a gateway or a firewall, you can do that. Again, we have a lot of flexibility here in Verge. But in my case here, I'm going to go out my native VLAN, and then beyond that, I'm not going to turn on DHCP. You can if you want to, though. One of the nice things we do have in Verge is we make it really easy to stand up these internal networks with DHCP stood up so that you can do dynamic addressing without really any kind of headache. Yeah, if I go submit here, what did I forget to do? Oh, I never actually turned that back off again. So now that it's here, if I power this on, again, this is just going to be a container, a very, very small container. And you'll notice here, a VXLAN ID of 13. We do our VXLAN over multicast. And again, because this is an overlay, we have the increased MTU size as well. But this is now a network I can assign my VMs to, and they can participate in this 10.0.0/10.0.0/24 network. But much like an external network, we also have the ability to set up firewall rules. We can also have this have its own VPN. We can also have those networks have their own DNS server. There's a lot more to it. Another thing I like to do with either an internal or external network that I mentioned briefly before is VPNing. So in Verge, we actually support two whole types of VPN tech, whether it's going to be site-to-site VPNs, where I'm saying I want to join, one subnet at, some location to another subnet at another location. And I want all that traffic that goes between them. It might go over the public internet. I want that to all be tunneled and encrypted, and I don't want anyone to be able to see it. We support IPsec tunnels directly from any of these external networks. Or if you want to do site-to-site VPNs, you can also do it through WireGuard. But my favorite thing I like to do with VPNing is we also make it really, really easy to stand up a client-based VPN server on these networks. So if you're familiar with things like Cisco AnyConnect or the Palo Alto VPN client or any of those that you might have for laptops, just to securely access a work environment, we give you that out of the box with open source technology that is proven, fast, and secure. WireGuard is fairly new, I guess you could say, not really, really new, but within the last decade. And we make it as easy as just new WireGuard interface, and then you could just add peers to it. I have one here. I actually connect to it from my phone when I'm outside the office if I need to get into my office network. And it's really, really fast. It has much less overhead than IPsec, and it's a lot easier to configure, a lot less things to worry about. You don't have to worry about all the phase negotiations and things like that. But yeah, we make it super duper easy to get either type of VPN stood up on a network. And again, this is all without extra licensing. This is all without extra virtual machine overhead. This is all without, any type of third-party integrations. This is all built in to VergeOS, available for anybody to use.
Okay, so that kind of gives us a good look at what we could do with VPNs. Let's talk about firewalls a little bit. How do we set those up within the product?
Yeah, so that's all going to be done through this rules section. And
Okay.
it's going to be as easy as, let's say I wanted to block all traffic to any websites on this network. I would just say, block, web traffic, and then I'm going to say drop it for anything that matches TCP incoming and from anywhere to a destination of any of my internal. Actually, I'll make this related just to this network for this Verge network we have here. So This will just apply to the 192.168.37.0/24 network. And I'm going to block anything that's destined for 443 or 80. And once I click that, it will block everything for 443 and 80. So it's as easy as that to set up. If I wanted to block something for maybe SSH, I could block it for TCP/22. If I wanted to block, I don't know, NTP, I could block everything to, let's say UDP 123. So block NTP. And I could save that. And you will now see that show up at the bottom. So by default, we put all rules at the bottom. But again, you can pin them to the top and they'll be put under the already pinned rules at the top. And we do also allow you to pin rules to the bottom too. But this hasn't taken effect yet, much like other traditional firewalls. Once a rule is created, it does need to be committed to the active firewall rule list. And that's what this apply rules thing will do. So once I hit yes here, I am now blocking any type of NTP traffic that's incoming into my 192.168.37.0/24 network. For security, for the folks that deal with firewall administration on a day-to-day basis, just some other things to kind of make you aware of. We do allow the ability of these rules to be tracking their hits. These hits can be pretty much accessed via the API, but we can also have all of the hits for these rules logged as log entries. So if you have any type of SIEM system or any other type of security analysis system that can, essentially pool together info based on firewall logs, you can forward all of our logs to one of those systems for further analysis as well. So we do enable folks to utilize their existing security infrastructure.
Oh, that's really interesting. So let's talk about DHCP and what we can do along those lines.
Yep. So let me go over to one of my ones. I don't know if I do DHCP on this one. Do I? I do not. Let me go over to, I think I do it on,
And as you're watching this, I want you to notice how fast the interface responds. I don't think Bob is running on a quad processor box because I haven't signed off on it. So I'm assuming it's a kind of a vanilla dual processor box, and you can see the interface is incredibly snappy.
yeah,
Go ahead, Bob.
these physical servers were built in 2011. So to give anybody an idea, these are fairly old. I think these are running Ivy Bridge processors. So yeah,
Okay.
and you'll see, yeah, as George mentioned, very, very snappy web UI. Not a lot of waiting, not a lot of weird loading, like some other, virtualization web UIs you might be familiar with. But yeah, I believe I'm running DHCP on this one. Yes, I am. Okay. So for us, DHCP is as easy as you essentially would just define whatever network it's going to be serving DHCP addresses from. We then can define a scope or pool of DHCP addresses where, once I've turned on DHCP, I can then turn on dynamic DHCP and then define this pool where it's starting at, .100 and it's going to .254. I can also force it to give out those IP addresses sequentially if you want. But once that's done, and if I didn't have it enabled, I would hit save. I would just restart this network, which is because again, it's just a container in the background. We're just reinstantiating that container, and it takes a matter of seconds. This isn't a full-blown VM, which, by the way, kind of another advantage here of having these networks act as containers. They now no longer have the overhead of a VM, where something like, for instance, an NSX edge node might take a while to start up because it has to go through the full VM startup process. Um, but yeah, this is stood up and this is now serving out address space where if I were to, get a VM, put its NIC on this network, start it up, and if the guest OS is configured to pull IP addresses through DHCP, it's going to get an IP address in this range. And better yet, if you want to, you can even have a given VM's IP address locked in as a static address. Within the network, there's this IP address section where we track, the IP address usage of anything that's in that network. All you'd have to do to essentially make sure that a given VM keeps its IP and essentially has a DHCP reservation, just select the IP address that's in use. You go to edit, And then pretty much you'll just go and select this to be a static one, and then that's it. Once it's static, we will always make sure that, the VM and its NIC that has a given MAC address will always be using a given IP address. So we make DHP reservations really easy too.
That's amazing. Bob, so another question came in on how many networks, is there any limits to number of networks, number of firewalls, things like that in the product?
so tested limits are in the thousands, I believe. The one thing I do want to call out here though is for our VMs, if you're familiar with VMware, you are limited to 10 virtual NICs or VNICs per VM. You can do more with things like sub interfaces, but that kind of requires some work under the hood. For us, we allow a VM to have, I think it's up to, gosh, at least 256 NICs. So pretty much a factor of 100 times, if not 200 times more than what you get on vSphere. But as far as networks go, I mean, I think our tested soft limit is in the thousands, like something like 5,000 or something like that. So you can go pretty crazy with it if you want to. Again, all of our networks can be routed into each other. So if you wanted to set up something like a network playground or a network lab where you have multiple networks of various different subnets all doing maybe OSPF or BGP with one another, and not worry about that whole playground interfering with your production network, you can do that in Verge because we give you the ability to only limit what connectivity exists depending on what your needs and requirements are.
Neat. So, question. This is actually my question. So hopefully it's good. So explain to me. Obviously, we talk a lot about our multi-tenancy and our virtual data centers. Explain to me the correlation between that and the networking stuff. It sounds to me like there's some networking things that sort of overwatch multiple tenants, but is there things I can do specifically to a tenant?
Yeah, totally. So a tenant in Verge, just for the folks that aren't aware, is essentially another instance of Verge that is within a given Verge installation. Now, when I say, it's within it, it's not so much nested. I mean, it is to an extent, but we're not doing nested virtualization. So on one of my sites, I have a tenant, aptly named tenant one, and it has its own management web UI, which we'll log into right now. And you'll notice it's not much different than what a typical Verge interface is. But what's neat about this is it becomes its own operational boundary for network management and the VMs within this tenant. So you'll notice within this tenant, I have my own set of networks. And these networks are only going to be managed by folks with access to the tenant. You can even have a tenant where the upstream provider or the parent part of Verge can't necessarily mess with the rules or the networks you have in there. But there is still the ability to route out of these tenants into existing, level 0 or parent instance of Verge networks. And we do pretty much handle all of the kind of route rules and route injections from, the parent part of Verge into a tenant for you. We also do build in pretty much kind of built-in firewall blocks from one tenant to any other tenant networks. And all tenant networks essentially get their own VXLAN layer 2 overlays for their internal networks, much like how any other tenant or any other install Verge gets. So there's no real overlap with regards to layer 2 segments or domains. Heck, a tenant can have its own subtenants, and we actually allow, I think it's go like 5 or 6 levels deep, where we will have just, VXLANs on VXLANs on VXLANs if you want. But it gives you sort of a certain amount of sovereignty over your own network management, and it also gives you the ability to have this sort of isolated enclave of compute, storage, and also network resources that isn't available to other tenants if you don't want it to be, or the provider side, again, if you don't want it to be. That's kind of the key thing within Verge networking. If you want to route between all these tenant networks across different tenants, you most certainly can. We don't disallow it. But by default, we do allow it because, that's really the more secure option. I hope that answers your question, George.
Yeah, no, it's perfect. So if I wanted, and what made me think of it was, if I wanted to build sort of that playground, if I'm a listener here, like I had told you, I'm a storage guy, and if I wanted to kind of, my big fear with networking is I quite literally could break something very, very badly. Um, but could I create a tenant and then do all my testing within the, maybe between two tenants I create, and then even if I really screw something up, it's not going to mess up the rest of the network. Is that a safety precaution?
Pretty much, yes. That's
Okay.
because one of the other nice things about a tenant is, and honestly, even outside of a tenant too, you can create networks where you can do all sorts of crazy things. Like, I mean, as simple as maybe having IP conflicts on purpose to see what happens with those, or using the same MAC addresses across VMs to see what happens there, or maybe you're messing around trying to learn things like BGP and OSPF, and again, it takes a while to learn some of that stuff, but with Verge, it lowers that learning curve because we make it really, really easy to recover from any type of mistakes or mess ups because that's part of the learning experience. And I mean, speaking as someone myself, that's how I learned about a lot in networking was through having a virtual playground to be able to stand things up in, break stuff, and then restore really, really quickly to learn from my own mistakes.
Cool. So I want to kind of just wrap up with some of the diagnostic capabilities, but I want to remind everybody we've got some questions coming in. We're going to take all those at the end. So keep them coming. So, but Bob, the last thing I just want to kind of give me a look at like the diagnostics. How do I manage this? How do I know something's wrong? If something's wrong, things like that.
Mhm. So one thing that a lot of folks in virtualization, whether they work on the system side, networking side, or perhaps both, that they'll deal with is, claims of something might be wrong with the network. And, without having to go and point fingers at, any teams or anything like that, like I said, let's say I'll come back over to my one Bob site here. And if I go into, we'll pick that VLAN 37 again. There's this diagnostic section that exists for every network in Verge. When you go in there, essentially what we're exposing is a number of command line options applied to the container that's running these network services that allows you to pull out information very, very quickly to diagnose specific issues. So let's say, for instance, I just set up this network, VLAN 37, and I know, or I'm pretty sure I thought I had the ports on the upstream physical switch tagged correctly, but I'm still not getting connectivity. One of the first things I would do here is I'll kick up an ARF scan, and then once that's done, you'll notice that I have a number of things that I pretty much picked up. And one of those happens to be my upstream switch. So this 37.1 is actually a port on the switch I have north of this network. I could then just pull the ARP table itself if I want to, and this will give me the ability to see very quickly, do I have L2 adjacency or am I at least communicating over L2 to some sort of physical port? Now, that's on the very simple side of things here. We also allow you to do just sample DNS lookups directly from the network itself if you want. We also give the ability to go through and run pretty much anything around, BGP, OSPF, or EIGRP, and pretty much give it output here. Another thing, though, I really like a lot about Verge is by default, we actually build in Nmap to every Verge network. So if you want to do scans for open ports, whether it's, VMs that are within that network or perhaps VMs or services outside of that network, you can do it from this specific network. And you're doing it from this specific network too. You can also just ping things directly. But the other two I really like a lot are the ability to do essentially a netcat TCP connection test. So from this network, maybe I needed to see if I can hit this site here. Yes, I can hit it. Maybe I need to see if I can hit, I don't know, Verge.io itself. Well, the good news is I can. Or you need to see if certain ports are open within that network itself, whether you're doing firewall rule testing or just checking for connectivity. And then lastly, and in my opinion, probably the most important one here, is the ability to do a full-blown TCP dump from the perspective of this network, and you can pick which interface of a network it's using. So a lot of network folks, for dealing with any type of issues, one of the first things they'll want to see is a packet capture. So I could just simply say, okay, I got a packet capture here. You can configure capture rules if you want. You can also, show any link level headers as well. Just again, we try to make it as easy as possible for folks to run. But I'll run this on high. I'll click send, and pretty much this is configured to only show the first 100 packets I capture, or it'll just stop after 15 seconds, whichever comes first. And you'll notice here, I'm getting a full-blown packet capture of not just the VMs that are within this network, but also from traffic that's entering and exiting this network. So we also do capture ingress and egress. And then I could take this and I could send this on over to my network guy, or I could share this with, team members just to, show them that, hey, this is what the current packet captures are looking like for that test you're trying to run. And this is
Very
all
cool.
available real easily from the perspective of any given Verge network without having to stand up like a VM, install Linux on it, and then run these tests. You could just do it directly on the network here without those extra steps.
And you can flip between the tests really fast, like you were doing, things like that. I think there's a lot of good stuff there for sure. Um, so a question came in on the rules.
Mhm.
Is there? And I'm glad they asked it because I was thinking the same thing. Is there? Do they execute in sort of that priority order, and that's why you
Yes,
pin things, or is that the
correct.
reason behind that?
Correct. Yeah. So the way we run our firewall rules is we process traffic flows from the top of the rule list down so that once a flow or a connection attempt matches something, it's going to follow whatever directive is assigned to that rule, whether it's accept, reject, or drop. So I have
Gotcha.
some more important ones here, really just simple ones where I want to be able to ping, the router IP address, and I want to be able to ping uh specific IP address within this network as well too. That's all. And
Cool.
then a default route and then a NAT rule for my WireGuard server.
Gotcha. All right. Well, Bob, first of all, thanks. That was really informative. So let's tackle some questions if you're up for it.
Totally.
Let's see. How does the VergeOS solution compare uh, to traditional compliances in terms of performance and security?
So much like other software-defined networking solutions, I mean, we're not running off of dedicated ASIC, hardware on chips, but at this point of where everything is, the differences in speed and processing power is fairly minimal. I mean, yes, you will always get faster speeds from ASICs, but what used to be a much larger gap is now much, much smaller. And to be quite honest, the benefits gained from how quickly these networks can be stood up, configured, and even duplicated makes up for any difference in packet processing speed. But let me be clear here. We still can operate at, normal line rate with regards to processing packets for the firewall, just routing things. I've tested flows going all the way up to, shoot, I mean, 50 plus gigabits. I know we support 100 gig networks. I know we support 400 gig networks. So, yeah, we still process things at a line rate. It's just, again, dedicated hardware, regardless of the task, is always going to be faster. I'm not going to tell you that software is going to be faster than hardware by itself, but we also do take advantage of some features under the hood with regards to kernel tweaking and offload for certain aspects of network flows to help speed things up.
Okay. Um, so obviously we've shown a lot of areas where we could essentially replace, firewall VPN routers. Are there situations where a customer still might want to have dedicated hardware?
Yeah, so if there's a need or either it's compliance related or just a desire from a security team to do something like layer 7 inspection. So as of today, Verge, we don't do anything above layer 4 with regards. We're not going to open up packets, see what's within the packets, and then kind of categorize or you know sort of evaluate things based on what's in the application flow itself. So we're only really operating at layer 3 and 4. If you're trying to do any type of rules or inspection of those packets for whatever reason, that would still best be served by some kind of a hardware appliance. But a lot of those same vendors do also have virtual versions of those that will work in Verge as well. So again, that's also another option there too. But I would say the biggest thing in terms of hardware is going to be, yeah, if you want that quote unquote deep packet inspection, that's still probably best done in hardware.
And that actually sets up the next question, I think, pretty well. Uh, does the customer, so let's say they love everything you've done, they're like, I want to hire Bob, this is awesome. Um, do they have to take all their, if you will, smart hardware and throw it out and go buy some new dumb hardware, or could they kind of gradually migrate over?
You can gradually migrate over. So we make it really, really easy. Again, we can have networks participate in existing VLANs. Whether you're trying to do like a physical to virtual migration or a virtual to virtual from, whether it's vSphere, Hyper-V, other KVM servers. Um, Again, we allow you to kind of stand up the landing spot for a given VM, whether it's going to be in the same subnet. Even if you don't want those VMs communicating to the existing ones, you can set up the same subnet, just route it out to somewhere else, and we're doing natting instead to make up for it. And that way you don't have to change the IP addresses on your VMs, and it could be as seamless as a migration as possible at that point.
So I can kind of, you know, I guess the way I could look at that is I could start replacing stuff as they come off on maintenance or, hit end of life, but, get the full life out of them before I start doing that,
Totally
right?
correct.
Cool. As somebody transitions from sort of this more proprietary hardware type of solution to a software defined solution, what kind of challenges should they expect in that transition?
So, like anything, there's going to be a change in mental models and how one thinks about where they are going to go to for rules and how those rules are affected and where they live. Because we're doing everything in software, one has to take into account that, the location of where a given IP address is isn't always going to be tied to a specific hardware entity. Now, that said, in Verge, we do allow you to pin a network to a specific hypervisor. So if there are requirements to always ensure traffic egresses out of a single, physical point, you can still do that. But by default, that takes away from a lot of the flexibility of doing things in software because now we're no longer tied to that hardware and we are able to, keep availability of those network services without having to worry about particular pieces of hardware going down. So the one thing I think I've noticed the most in working with other network admins is that you can't just assume this thing, single physical port is always going to have the traffic you're expecting. It could be coming out of another hypervisor into a different switch port. So that's one of the mental model changes you have to take into account. But then the other one is that you also now have to take into account that these are networks that, again, are defined in software, but they can also be modified in software. And what that also means is they can be automated very, very easily. Where in the past, you can have a script that sets up, a switch config and the like, and that kind of works. But with Verge, not only can you just define your switches, you can define all of these services on those switches or networks or routers or what have you, and other routers simultaneously. And we allow for folks to actually stand up networks with our Terraform provider. So we do have data sources for networks in our Terraform provider. It's currently out public in the open. Source code's also on GitHub too, if anyone wants to take a look at it. And that also helps speeds up the creation of networks to the point where I can define a TF file with, I don't know, 80 networks, and if I go say Terraform apply, I'm immediately making those 80 networks with all their separate IP addresses available, all their services already on and ready to go in a matter of seconds, versus having to SSH or serial cable into a given switch or router, or perhaps you're using a particular networking vendor's web UI that takes a long time to load. Not going to mention any names, but that can take a while. And you can script all that with existing known open source technology that we make available to you.
It, what you were just talking about there kind of, this is another George question, but it triggers a thought. It seems to me like we would have an availability advantage versus, say, like a VMware NSX, I'll say it, or something like that, because you got to make sure that all those VMs that you had mentioned earlier, they've got to be up and running, right? If the server running that VM dies, you're kind of in
Yeah.
trouble.
Yeah, no, on the NSX side, there is the ability to get some sort of redundancy, but at the cost of additional resources. If
Right.
you want to have two, three, NSX managers, you can, but you're going to be using up about 90 gigs of RAM alone just for those three VMs. While in us, because we rely on containers, we don't necessarily even have to keep up two separate containers. We just instantiate a new one, and the instantiation of a container is infinitely faster than powering on a VM.
Sure. Yeah. Okay. Cool. Let's see. Just kind of going through these real quick here. So we showed the diagnostics. How does the ability to troubleshoot this compared to, say, some of the software and or hardware solutions that you've seen on the market?
So I'm a very, very big proponent of keeping all teams in the loop. One of the things I like to tell folks I work with is, allow readout only access to switch configs. Make sure that, sensitive things, passwords and the like are blanked out or encrypted, but um, allow read only access to folks and allow systems teams to see what the switch configs are. And heck, even allow access to maybe the change logs of those switch configs. In Verge, we keep track of all changes to all networks within our audit logs so that they are available to anybody. And then another thing about these too is folks can do diagnostic like actions without one, interrupting dedicated network personnel, and two, without causing any interruptions or issues to the network. So some network folks, are a little apprehensive about giving systems people access to either the switch configs or maybe some diagnostic tools to run from a switch. Heck, I would say most network providers don't usually give their system folks access to maybe log into the switch and run things like, give me the ARP table. Usually those same network admins will get constant emails saying, hey, can you run this packet capture? Hey, can you run, give me the output of what the ARP table currently is. And rather than deal with that back and forth through email, Slack, text messaging, what have you, folks can just go in and do it themselves, and they can see for themselves what is actually in an ARP table, what is actually working as far as connectivity between this network and somewhere else, what is the actual firewall rules configured for a given Verge network. I want to kick off a trace route from this network to somewhere else. I can do so, and that's not going to be a problem. I can do things like, pull my public IP address from this network. And then I can also see things just like generic logs. I can do, again, my own scans, my own connection tests, pings, port scanning, all without having to eat up the bandwidth of maybe my network administrators, or I'm able to get a more educated kind of a working relationship with my network administrators where I can say, I'm pretty sure it's the network, but I don't know, why, versus it might be something on the switch config and here's why, and I'm able to provide more information like, this is what I'm seeing in the packet capture, this is what I'm seeing in my ARP tables, and now we're not having to go through the dance of back and forth, for however long to try to figure out an issue that can honestly be solved in maybe 5 minutes or so.
Okay. It is kind of tying on to that, and then this will be the last question. Is there sort of a way to limit? Like, I can also see the opposite, where if I'm the Verge IO administrator and I got a guy helping me, I might not want him going around monkeying with network settings. Can I control that as well?
Yeah, totally. So we allow you to have like full read-only access or no access whatsoever to the entirety of anything network related in Verge. Even down
Okay.
to if you want to disallow people from, changing a VM's NIC to a different network, you can lock that down as well. So everything in Verge, even outside of the networking, has the ability to, per user, allow for create, list, modify, or delete. And it's really just a checkbox item for each of any type of object in Verge, whether it's a network. Maybe I only want them to see that the network's there, but not do anything in terms of rule changes or IP address changes. We can do that. We could just hide the entirety of networks from users altogether so they can't even see it. That can also be done. Or maybe you want to give your network administrator access in to see and do some of these diagnostics, but not have access to the VMs. You can do that too.
Okay. Well, great. Well, Bob, hey, this was very, very good. Thanks very much for spending the time with us today. I know I learned a lot. Hopefully, our listeners did. So I appreciate your time and appreciate the demonstration.
Awesome. Thank you so much, George.